Hello everyone, welcome back to this latest video on how to build a falling sand game in Bevy using Rust and WGSL. So last time we got to the stage where we actually had our compute shaders initializing and we were able to draw some different colored pixels basically onto the screen. So we had if location, we basically set the pixels to green unless the location on the x-axis was greater than 500, in which case we set them to this sort of bluish color. So there we go, that kind of proves that we are running our compute shader and it's updating to the screen. But this is only the initialize function. So now we've done that, I want to move on to the update function. But also, this is kind of dull, just setting blocks of color like this. Remember, we're building a falling sand game, so I want to create some like random sand just to get us started. So in order to do that, we're going to have to create a random method in our actual compute shader. And to do that, we're just going to copy an existing implementation of this. We don't really need to worry about why this works. But basically we're going to use a hash value and we are going to divide it by a magic number, and that's going to give us a random float value between 0 and 1. So this is the hash implementation. Again, you don't really need to know how these numbers are derived or anything, but just it's not a particularly great random number generator. You'll see it has like quite bad periodicity, but it doesn't really matter. It's good enough for our purposes for now. So I'm going to put that in there. This is basically straight out of the Bevy shader playground example code. So now then, I'm just going to change what we're doing here. So instead of just setting it if, so we want basically the default to be air. Alright, so air color, we want that to be, basically we're going to use black, but I'm not going to do jet black because I don't really like using jet black. We're going to use this, which is nearly black, and then so that's going to be the color of our air. And then output color, if you like, we're going to set that to air color by default. And then let's just run this and make sure we're basically getting a solid black screen with no compilation errors. Yeah, it's looking pretty good to me. Okay, and then we're going to crack on from that. So, and now I'm going to use the random function, the random float function, to decide whether we're going to put sand rather than air. So, set it to air by default. Now we're going to random number. I'm going to call our random float and then use the invocation ID because we have to pass in basically a seed value, and we'll follow along what the tutorial does. So it just uses the work groups invocation, all right, and then is sand. We're going to have if random number is greater than 0.99. So quite a low probability of being sand. And then if is sand. And we haven't actually specified what sand color is going to be, so let's put it up here. And this is going to be yellow, so red plus green, pale yellow, so pastel yellow. Okay. Just going to move these around a little bit to make it a bit clearer what's going on. Okay. And now, all being well, if we run that with Shift F10, we should see... There we go. So now we've got some random sand. Random sand particles. Okay. So that's great. Okay. So I think I'm going to save progress there. Have a look. Yeah. Commit. Add random sand to compute shader init. All good. Okay. So now that we've got that, we basically want to move on to actually making the sand fall. Okay, and in order to do that, we are going to need to do the update part of the pipeline. So if we go back to our pipeline, and at the moment update is empty, so we just want to basically run I've just noticed this is not quite right, so it doesn't really matter, but we were calling update once after we'd initialized, and really we don't want to be doing that. We want to be calling init when we are actually initting, not when we're loading. So that goes there, and then what was in there now goes there, so we're actually calling... Oh no, hold on. It was right. Getting confused. Update pipeline. Yeah. Yeah, I think basically this should be get state at. So if we are in the state loading, we then set the state to init. That's good. If we're in the state init, set to permanent, and if we're in that, it's all a bit of a mess, isn't it? Let's just check the actual shader playground code. Bring that in over here. It's in update, it's in loading, we do that, it's in init, we do that. Okay. Within the run function. I'm being daft. Right. So I missed this here. So it's in the run function, not in the update function. That's totally fine. In the run function though, we want to handle this state, which we aren't handling yet because we're just basically ignoring it. So let's do so. So loading is fine. And update is we want to create the update pipeline using the pipeline cache, get compute pipeline, and the update pipeline is what we want. Let's mercilessly unwrap it there and set pipeline. We want to set it to the update pipeline, all good, and dispatch same as in the actual init, but I'm going to type it out just for fun. Divided by workgroup size, and then this is the simulation size, second element of the tuple, workgroup size, and 1. Right, there we go. That's the end of that statement, and that should be happy days. Right, so that's the Rust side of things handled. I'm just going to run to make sure we haven't made any boo-boos, which obviously we have. And that should be alright. Takes a while to compile, but once it's running, we're basically going to now modify our update part of our function. Compute shader, that is. Alright, so is there a way for us to have a global rather than duplicating these locally per function? Let's have a look. Might be able to use const to do it. Let's try. Set the air color. And now if I get rid of it here, let's see if that works. Should be a const. Really, I should make this uppercase convention and modify it here. See if that works. Shift F10 to run. Okay, looks good. Great, let's do the same for sand. sand color. Lovely. Right, great. Okay, so now back to the update function. So what we want to do here is basically be able to check our neighbors. So first of all, we want to get our current pixel, our current location. We can do that from the invocation ID, X and Y values, because our simulation size corresponds to our pixel size. For all intents and purposes, the simulation size is the only thing we care about. So we get the location, and now we want to find out what we currently are, right? So current particle, and we can use texture load for this because we're going to be, reading the value of what's already in the texture. Okay. If it's air, we want to do nothing, but if it's sand, we want it to fall. So let's see if WGSL has like a switch statement or something like that. And really, I should just realize that I'm actually doing things in a separate window. So WGSL switch statement. Let's have a look. Okay. So we switch. Case. Switch condition must be concrete integer scalar type. Which is not. So I don't think we can actually use that. Because our colors are a 4-component vector of 32-bit floats. So we could try and change the types, or we could just do a cascade of ifs. Like if we're sand, it da 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 da. Let's try it like that. So if current particle color is equal to air color, is that what we called it? Yep. Basically we want to do nothing. Else if it's sand, just realised I haven't closed that. Otherwise, if it's sand, check below and fall if we can. If not, select a random direction, diagonally down, and try to fall there. Hopefully that makes sense, but we don't know how we're going to do that for now. But I just want to check that our actual logic here is working. I do not know what the style should be there. Let's just make that like that. So let's just modify these values with a texture store. So I know it says do nothing, but let's texture store texture location, and then we will just make another color, random color for debug purposes. That's going to be white. So if that's working, it should set all of the air to white basically immediately. Let's have a look. If condition is not Boolean scalar. Okay, so we need to figure out a way to match on colors. Let's have a look. Binding points analysis. Okay. Just poking around in the WGSL tool. Array structures. So basically, we've got a vector. Vector constructors. Element-wise conversion. Alright, search it. WGSL comparing vectors. Okay, so execution test for equality. Let's have a look. Not a Boolean scalar. Let's see if we can search this actual exact error message. I might actually need to read the spec. Syntax. Scalar type. Okay. Matrix types. Yeah. Yeah, that one we all saw. Expressions. Vector access expression, maybe. Maybe. Could we bitwise compare them? OGSL compare to I wonder if we could do RGBA like this. Let's see if that kind of deconstruct them out like that. Guesswork at this point. Let's have a look. Sometimes you just got to tinker around when you're learning a new language. So it's basically the same problem. Not a Boolean scalar. Okay. Quality. maybe GLSL give us vector relational functions. No. Do we have any vector functions defined in the spec? Let's have a look. Plane types, memory views. Memory execution, built-in functions, value constructor. Construction. Yeah. It's just the constructors. Oh yeah, value constructors. Any or select. Derivatives, data packing. Let's try it with just like see if that actually works. So we're just going to compare basically the first component just to see if decomposing it out to one value is actually going to please the compiler. Yeah, okay. So it will at least do that. I don't really want to, you know, do like R, G, B, A. That seems really long-winded. There must be an easier way to do it than that. Can't read in the spec. Or maybe we could see some examples. Yeah, the tour of samples. Let's have a look. Yeah, fractal cube. Looking for an example where equality is used. Okay, game of life. It's kind of similar. Computer shader. Okay, so this is using a storage buffer. Select. Count neighbors. Yeah, it's also got a next buffer as well. It's probably what we want to do as well. So it reads the values out of the current buffer, does the business, and then actually writes it out to a next buffer. Otherwise we're going to be modifying things whilst checking them, which could mean we run into problems. So we want to do more like a ping pong kind of setup. Also, it makes me think I'm possibly thinking about this all wrong, rather than doing if statements inside the compute shader. Let's have a look at what select does as well. See that a few times. So we want select, this select method. Let's have a look, see if we can find it. Oh no, not save, select. Logical built-in, all, any. Ah. Returns T when the cond is true, F otherwise. So we have a select here. No. It's not great. Stack Overflow. Similar to what we're doing. Not really much help. Maybe Bevy has some examples. Doesn't look that helpful. Numeric abs, no. Yeah, numeric built-in functions aren't really going to help us, I don't think. Could we do... Maybe we could use distance. Okay, let's try it. So if we treat them as vectors, if you think about it, the distance should be 0. or less than a very small value. I don't, yeah, I guess we should do, is epsilon built in? Let's have a look. Let's define it. Okay. Alright, so let's see if that compiles. Feels a bit kludgy, but I don't know if there's another way to do it. I'm writing it out longhand. Doesn't seem to. Right, sanity check time. Let's just completely remove our conditional logic and just actually store white color here, just to check that it's actually working, doing anything in the update function. Okay, it is. That's good. Hold on. Still doing component wise. I mean, one individual component. Let's just actually do the whole vector. Still not working. Distance. It's talking about accuracy. Length. Maybe we could just do length. Hold on. Getting daft. Length of E1 minus E2, yeah, of course. Maybe, I mean, surely it's not the fact that our epsilon value is too small. That would be gross. Ah, but it is. Okay. Alright. So I guess the accuracy isn't as much as I thought, so let's try 1000. Okay, cool. Alright. So it's probably a bit gross, but let's try it. Let's go with it. so now we know we're absolutely fine for detecting air. So that's cool. Basically do nothing. Now we want to check if we can detect sand okay. I mean, just for sanity's sake, let's actually bring that back and change the sand to something else, just to show we can. Let's change it to like a horrible grey colour. Run. Does that work? Let's not change it to a grey colour, let's change it to white because I couldn't see that at all. Bizarre. Okay. What's happened there then? It's a bit strange, isn't it? We just seem to have lost everything. Oops. Let's just comment that out. Rerun it for sanity's sake. Okay. We possibly had a compiler error. Let's have a look. Nope. Oh, no, it's working. Okay, bizarre. Right. Okay. So we can now detect our block colors. Excellent. Okay. So now we need to. Well, let's just think about it. Should we just make them fall straight down to begin with? So how do we do straight down? So this is basically going to be so we start in our texture. And then a 2D vector that is x and y. Alright, so x is 0, y is -1. Okay, and what are we going to store there? We're going to store sand color. Oh, hold on. Yeah, this is also really daft. So this is basically saying if we find sand, just put sand below it as well. So it should kind of like write streaks down the screen. But it writes nothing. Quite bizarre. Let's run that again, because I don't actually believe it was doing the right thing. Failed to process. Text store. Texture store. Okay. Note to future self. If it goes black, check for compilation errors. Oh, right. Okay, cool. So, well, we're doing it the wrong way round, but that is actually doing the streaks as we thought. Boo, down they go. Nice. Okay, cool. So, if you think about it, what we actually want to do is erase ourselves and add ourselves one below. So, replace ourselves with air, and then put sand below us. Let's try that. Alright. Well, that kind of looked like it fell. Now we want to... Really, we need a barrier, don't we? At the bottom of the screen, so that it can actually pile up. Because when we run it now, the sand just falls and off the bottom it goes. What frame rate are we getting? Okay. Still getting a very high frame rate, so pretty happy about that. Not sure how optimized this actually is, having like if statements in your compute shaders. I'm a bit of a noob when it comes to writing GPU code, so I've got a feeling that's bad, but it might be alright. So, right, let's define another... Okay, I'm going to save where we got to so far. Make sand fall in update. Shader method. Okie dokie. Yeah, let's make another type. Let's make stone. So the idea of stone is that it will just be solid and stuff can't pass through it. So let's make it a darkish grey colour. And let's put make it so that the bottom of the simulation has stone all over it, basically. It's covered by stone. This is a bit quick and dirty, but it's only going to run once, so it doesn't need to be all that optimized. So we're just going to make the bottom, and also, yeah, there's a magic number there, which we'll sort out at some point, but let's just get it working first. Make stone at the bottom. Obviously that's going to, yeah, I want Y, not X. And we totally ignore it in our update shader, but that's okay. So yeah. Okay, at the moment it falls through the stone, which isn't the end of the world, but we can at least see it there. Right, we've got a bit of a line of stone at the bottom now. So let's just add a comment for what this is actually doing. Add a stone barrier at the bottom of the screen. Alright. Add sand sprinkled around randomly. Alright. Okay, so now we want to check if we've got stone below us, don't fall. So if, right, so we want to read the location below us. So we'll do that with texture load. From the texture, and sort of in the similar way to how we were storing it, we do location plus vec2. Should make some helper methods for this really, shouldn't I? 0, 1. Right. That gets the color of color below. Alright, and if color below, so we now want to check if it's stone. And if it is, we still want to do that at some point as well. What do we want to do? We basically want to, yeah, if it's stone, do nothing. So if we're directly above stone, do nothing. Also, if we are directly above sand, we want to do the same, although we want to fall, yeah, diagonally down, don't we? Okay, hold on then. So let's just leave it, let's just sort out the stone for now. I do realize that this means that we can fall through sand, so it'll look a bit weird, but we should at least end up with do not fall. This should be, if there is yeah, okay. No, that, yeah, alright. So no matter what, I'm just thinking ahead to the fact that we're going to have other blocks. We do want to, no matter what the block is, try and fall left or right to basically flow off it, because we're sand. So let's just see how this works. Alright, so now we fall, and the sand, like I said, falls through itself and kind of disappears, but at least falls down onto the stone and stops on the stone. So that's pretty cool. So I think basically we want to compare this to air and fall if there's air, because that's fall straight down. Fall straight down. Okay. If not, select around. So we know there's a block here. There is something below. So we want to select a random direction diagonally down and try to fall there instead. Alright. So if I just run that again, it should do the same thing. Ah, now the sand piles up. Yes, of course. Excellent. So now we've actually got falling sand falling onto stone, but it's not flowing quite right how we want the sand to flow. but not bad. It's getting there. If I increase the density of sand a little bit, we'll see. So let's make it more like 90, 10% sand. Let's have a look. Ah, there we go. The sand's piling up. Nice. Okay. And what frame rate did we get? Yes, still within sort of 450, 525 frames a second, so that's working quite well. And alright, I think that's probably a convenient place to stop for this week's stream. Next week we will implement the actual falling part, the sideways falling part, so the sand will flow to the sides like sand is supposed to, rather than just stacking up like we've got these tall vertical peaks here. It'll form more like mountains. And then once we've done that, we can start to think about adding water and other different types. I also think we might run into this problem where we are modifying the actual texture at the same time that we're actually like looking at it. So this is probably going to cause us problems as we get more and more things further down the line. So it might be a good idea at this point to switch to buffers and essentially have a ping pong buffer situation where we're going to write to a new buffer whilst reading from the old buffer, which is the way you'd want to do it, really. Yeah, okay, let's save the progress where we got to so far. Add stone and only fall if air is below current particle. Alright, great. Alright, thanks for tuning in. Nice to see that things are shaping up a little bit, and see you again next week.